We're going to pick up this class with where we ended there today. What we looked at was calculating the spring constant, and calculate spring constant is take your force and divide it by the distance the spring is compressed or stretched. And that formula is given here. And that can be rearranged to find the force, and it's your constant times the stretch or compression amount. We went through question A here. It stated that car has spring constant of 2,250 newtons and it has 4 springs holding it up. Then we had to calculate how much springs were compressed on a 1,100 pound, or sorry, a car that weighs 1,100 kilograms. So we already went through this one, so I'm not going to repeat it. Question B, how much further will the springs compress when the car is carrying 4 passengers with a total mass of 350 kilograms? Okay, so first thing we're going to do is find out how much force in total is pushing down on the car. Remember, the force is caused by gravity, so you're looking at the force of gravity. So how much force is acting on the car to compress the springs? So the car now weighs 1,430 kilograms. You take your mass of the car from up above, and you add on your 330. So this mass here plus your 330. And that's going to give you your new mass of the car, load of the passengers. Force of gravity is 9.8, or acceleration due to gravity is 9.8. So then the force that gravity is pushing down on the car is 14,014 newtons. Now that's on the entire car, and remember that the car has 4 springs. So how much force is pushing down on a single spring? You take your complete force and you divide it by 4. So each spring has to hold up 3,503 newtons. Now we still have to find the amount that's compressed. So we take the force and we divide it by the spring constant. So your force divided by the spring constant is 1.5 meters or 1.2 meters. Now what you have to remember is that's the complete push down on the car. So what we already figured out was that non-loaded car will push down 1.2 meters. We're going to find out how much extra. So if you think of it this way, here's your spring. The car itself, say, would compress the spring down this amount, 1.2 meters. When you fill the car with passengers, the spring is compressed even more, and in total it will be compressed 1.557 meters. So how much extra was it compressed? What you're trying to find is this part right here, because it was loaded. So this is an unloaded car. And here's where the car is loaded. So to get that amount, you take your complete compression, subtract from the 1.2, and you find out that the car is compressed 0.35 meters or about 36 centimeters. Now, springs can also store energy. What we covered last week was that you could store energy by gravity. If you had an object, let's say a heavy weight, and here's ground level, and if you lifted that weight up, so it was like this, that because of its height, it would have gravitational potential energy. Mass times gravity times height, and you can think back to the pile driver example I used. Well, you can also do that with a spring, and you can store energy in a spring by either compressing it. So in this case here we have a spring that doesn't have any force acting on it here, and you can compress the spring down. So if you look at the height here, say just where the neck of the spring is, right there, and you compare it now, you see that the spring's been compressed. And if you were to let the spring go, it would extend back out. Or you can stretch the spring, and you're storing energy that way. And if you let it go, then the spring would snap down in position. So springs can store energy by either being stretched or by being compressed. Now what you need to know is that in either case, the amount of work done on the spring here equals the amount of energy stored in the spring. And that's called elastic potential energy. So 3 types of energy you covered. Gravitational energy. Then we looked at energy due to position, as something's moving, kinetic energy. And now you have elastic potential energy. And there's a formula for that. So the force of spring will vary depending on how much stretch is applied. So the force is the spring constant times how much it's stretched. So your spring constant multiplied by the amount of stretch or compression. So as you increase the stretch, as you make this number, as this number gets bigger, as you increase the amount of stretch, then the force a spring holds would also increase. Now the average force on a spring will occur at the midpoint, or the halfway distance. So instead of going through all the details there, and you can go through them if you like, here's the part that you need to remember. To calculate the elastic potential energy in a spring, it's half k times x squared. And remember, x is the amount of stretch or compression. So the example I want you to try is the coil springs on a truck suspension have a value of, and roughly about 74,000 newtons. When the truck strikes a bump, the springs briefly compress by 5.5 centimeters. So how much energy is momentarily stored in each spring? Okay, if you had time to finish it, we'll go over the answer. Okay, find the elastic potential energy. Use the formula there. Put in your spring constant and then the distance. Remember that the compression was given in centimeters, so you need to change that to meters. Now when you're working this out, remember guys that you need to square your compression first, then multiply by your spring constant, and then multiply by a half. Okay, another example, I'll read down through it, then you take a couple minutes to finish it. Suppose that spring constant for the toy gun shown there is 420 newtons per meter. How much energy will be stored in the spring? Will it be compressed 14 centimeters from the equilibrium position? Now, equilibrium position means when the spring is at rest. So if no force is acting on it, this will be considered equilibrium position. And then similar calculation as the last example. Put in your spring constant, the distance that it was compressed. Don't forget to square it, and it should come back with 4.1 joules. Spring is attached to a ceiling, has a mass of 500 grams suspended from it, causing the spring to stretch 4 centimeters. Calculate the spring constant, and from there how much energy was stored in the spring. So again, work these out first. So to find the spring constant, you need to rearrange your formula here. So to get K by itself, divide both sides by X, and your formula is now rearranged. Force divided by the compression, or stretch amount. So your force is, since the spring is hung from the ceiling, so you have your ceiling, and your spring, and then you're hanging the mass from it. The downward force comes from gravity. So here you have a mass times gravity, and don't forget the mass has to be in kilograms, divided by the distance that is stretched, and centimeters has to go to meters. And now you have your spring constant. And the last question, how much energy is stored in the spring? So you need to find the elastic potential energy. And same calculation as before. Alright, that finishes this section.